Alright, this is a video for Lab 7, and we're going to start uh, on the FEM. So today's lab will talk about, start the FEM and the SIM, and we will modify the CAD in the idealized part. So after we modified the idealized part, we will make 3 pieces of mesh on the idealized part. Alright, so first, let's start the FEM and the SIM. So you want to download this zip on web course. So that's the model we provided for you to make the FEM. Then once you download that, you want to extract all the files in one folder, and you have to extract every file. Okay. Don't worry about the FEM and the SIM here because I have this model already. So you should have the PRTs, and this one is your assembly for the CAD. Okay, so that will be the results for Lab 7. Okay, let's close this. And once you downloaded the file, you would have these files, and you want to start the assembly. Okay, this is a simplified assembly for our and see. All right, so download the first, extract, then start the FEM from the assembly. All right, so what we do first, we go to start and start the advanced simulation. All right, now we are in the advanced simulation. You want to build the FEM and the SIM. So it's just like the homework you have been doing on the class. So new FEM and the SIM. Okay, and make sure you check this create idealized part. And the solver is Nastran structural, and click OK. Alright, now that's the solution. We can simply click OK, and this will bring us to the SIM. Okay. If you go to Window, we can see SIM, FEM. The PRT here is your assembly, and we have this one is the idealized part. So the idealized part is it's like a copy of your master model. So we can simplify and modify the CAD on the idealized part without affecting your master model. Okay. So let's go to the idealized part. Just switch to this window. Okay, and just click OK here. Now we have the part. As you can see, we don't have any individual part here. It's just a whole piece in the idealized part. Alright, so the idea is, if you remember the model I showed you, we will use 2D shell mesh for the connection bar and the handle to simplify the FEM. And as to the upper jaw here, we will only mesh half of this, then reflect the half mesh to the bottom. So this way we have a guaranteed symmetric 3D tetra mesh on the upper jaw. Alright, so since we are in the idealized part, we need to modify this 3-piece for today's lab. Okay, so before you modify the pieces in idealized part, you need to promote them. So that's the command, promote. Okay, without promoting, you cannot do anything on the part. So first you want to promote and pick 3 of them. Just click OK. Now next, we're going to build a 2D mesh on these 2 pieces. So we need a mid surface for these 2, where we can build our 2D mesh. So let's go here, and you have mid surface by face pairs. Now we are going to use this command for this first. And if you notice, we simplify the model to make it like a simple extrude. So you have the top and bottom surface. So let's pick the handle and make sure this one's progressive. Then we can just click this button, automatically create face pairs. Okay, if you notice, we have a mid face that's created. So let's click apply. Okay, now we can keep doing for this connection bar. Okay, and again, strategy and automatically create face pairs. Okay, then click OK. Now we can have a look and just click on this promoted body, hide it. Now you can see that's the sheet body, the mid surface. Okay, let's move on to the jaw. So for the jaw, we are going to mesh only half of this, so we will need to split this in half. That's the command called split body. Okay, then we will pick this one, and as you can see, we cannot pick this handle, the lower jaw, because we didn't promote this. However, we can pick up the connection bar here. That's the difference between promoted and not promoted bodies. Alright, so go back to the upper jaw. You want to specify a plane. Okay, I think the default is the first one, face or plane. You need a new plane, and you can choose XY plane, which has the Z as the normal direction. That's why it's Z here. Okay, so that's our plane. If you click apply, you can see it's already half and half. Okay, so that's all we needed to do in idealized part. Promote, mid surface, split. Okay, alright, so we're done in idealized part. We can go back to the fan, and it's telling me that new faces are formed. Okay, so have a look at the polygons. Notice those two are different, so let's hide everything and then show this. Those two are the mid surface, okay, and the bottom two are the upper jaw, half and half. Alright, so we have a lot of polygons here. It's a good habit, you just rename the polygons so you can find them. Let's say this upper one, then that's the upper two. So you can name them as you wish, and we're going to continue on the mesh. Okay, so 2D shell mesh for this two piece, and the 3D detacher for the upper jaw. Alright, now let's go to the mesh. Let's see. Where's my mesh tools? Okay, it's in here. Let's see. Okay, so 2D mesh for the handle and the connection bar. Click this one. The element type is Q4. Okay, now Q4, 0.075 inch in size, and you make sure this automatic creation on the collectors. So 0.075, and you can show result. If that's good, then click apply. Then we move on to the connection bar. Then the size will be 0.05. Okay, and also we need another collector for the connection bar, since they are different thickness, probably different material. Okay, so that's all for the 2D mesh. Let's move on for the 3D mesh. Okay, So 3D texture mesh, and the element type will be texture 4. Okay, the size is the same as your handle, 0.075. So pick the upper jaw, half of the upper jaw. We can click OK. Now that's half of the mesh. All right. Okay. Now we can hide the 2D and the polygons. Now we have only this half of the upper jaw on the screen. Next, we're gonna reflect this to the other side, so we can have a whole piece of the upper jaw. So let's go to Insert, Element, and Copy and Reflect. Alright, so that's why we need to hide everything. So we can just box select the element on the screen, and you might have different numbers of element here. It depends on your computer, the mood of your computer, let's say. Alright, specify the symmetry plane. Again, we're gonna pick the XY plane, which has Z as the normal. That's why it's Z here. That's your symmetry plane, and you can preview, then click OK. Alright, so if you think about it, we have a half of the upper jaw on the top and another half on the bottom. So what happens on the symmetry plane? You have this many nodes on this plane. Okay. Now for the other half, you have the same numbers of nodes at the same spot on this plane. So you have duplicated nodes, right? And that's not good. So now there are two separate pieces if you run a simulation on this. And how do we tell? We can use the element edge check. This is a tool to check the external edge. Alright, now this element edge tool will show us the free edge, which is here, the free edge of a mesh. So the free edge is, if you look at here, it's the external edge of your solid. Let's say if like the situation we have now, that's the external edge of this the half of this upper jaw. Let's say if you have a whole piece of mesh, okay, considering this, if this is a mesh, you will not have the external edge on this, on the middle face or the symmetry face. Well, let's have a look. Okay, so we can pick those two meshes and generate element outline. And let's switch to wireframe. You can see there's one edge in the middle, okay, indicating this these are two pieces, not a single piece. Okay, so how do we get rid of this? We can merge the duplicated nodes. Okay, well, let's get rid of the blue lines. Just refresh. Okay, then go to duplicated nodes, and let's pick those two. And immediately you can see those nodes. They are so each dot means there are two nodes at the same spot, coincident. Okay, so we can merge the nodes. Just click here. Okay, now let's go back and use the element edge. Check this mesh. Bear in mind there are still two pieces of mesh. Okay, they're individual pieces. However, if you generate the element outline, you don't see those the free edge in the middle. So when you run a simulation, this one is considered as one a unified piece. Okay. All right. And the last thing is some information about the internal element. As you can see here, you might think the edges that's all on the surface, right? So if you think about it, that's 3D texture. You should have a lot of element inside, and it's not shown by default. And how do we show this? We can edit display for the collector, or you can right click on a single mesh, and you have this option here, display internal element edges. Just apply. That's a mess, but also you can see the element inside your 3D mesh. Why do we need this? Okay, so let's go back, and let's say I haven't reflected this. Okay, after I reflect, how do I know I reflected everything when I pick this mesh? The internal elements are not shown. So did I pick them or not? So we can just right click on the reflected mesh, edit display, and show the internal element. Now you can see, yeah, they are reflected, not just the outside of your 3D mesh. So this way you can just make sure that the internal elements are reflected as well as the outside, the external elements. Okay, so that's all for today's lab. It's pretty short, and thank you.